Hi, so we have a problem of fire and explosions.
Armin, frumos, puțin, rapid. Gata. A sărit?
So ever since we built the H1, I just could not stop thinking about what would happen if, say, a short occurred or some really bad event without me knowing it. Because the truth is that any lithium battery is just a dynamite waiting to happen. And what did we have in the chest of H1? Exactly, a 12S LiPo battery that was bigger than my face. And so with this problem in mind, I just started searching for a solution of what would be a safer alternative to lithium, which would be more abundant and also more environmentally friendly, because as you know, lithium is really hard to recycle. And the solution arrived with the sodium-ion batteries. They are a lot more abundant. We have much more sodium than lithium on our planet. They are a lot more safer, less prone to catching fire, and also they're easier to recycle. That and the fact that they're more stable across a wider range of temperatures. But of course, it's not all rainbows, because sodium batteries have a smaller power density than lithium batteries do. But it's just as in life, you give up something to receive something else. And in our case, we're trading power density for safety and a wider temperature range of operation. Not only that, but I wanted to have a project that was less expensive to produce, because so far we've been mostly relying on sponsors, and also my family contributed quite a lot. But if we want a project and maybe a product in the future that is easy to develop, it must also be a little bit cheaper to produce. Because I don't want to go to a project that costs more than 10,000 euros anymore. That's just way too much for me to develop it. And also, when you have a cheaper project, you have the ability to go for an iterative processing method, where you go from one version to another version and you improve the project through every single iteration of it, which overall gets some better results rather than going all in a single item, in a single object, because the object is a project. You're creating something physical and then, well, expecting it to work, because there will be things that will not work in this first iteration or so. And so, while thinking of what would be cheaper and easier to produce for me, I was like, well, we have batteries, so why not do power banks? And power banks we ended up doing. And so, just to understand, all of this internal meditation that I had happened right after the Robot Challenge competition in Bucharest. So after about 1 month of work, on the 12th, 2023, I ordered the very first prototype for the PCB, which was this, and it looks really big. And it is really bloated. Like, just check it out, how many circuits, how many inductors, huge inductors. I didn't know we could just increase the frequency and have smaller inductors. But anyway, just look at this. It looks like the PCB of your computer if you were to remove it from its casing. And the problem with this is that I actually relied on a very old saying in the electrical engineering space, that there is an IC for everything. And yes, there may be ICs for everything, but when we're talking about newer technologies with a battery that has a different voltage range, well, no, there are no circuits that are able to manage it or distribute its charge. Also, this PCB didn't really have any kind of possibility to customize its behavior. Like, I was relying on exactly what the manufacturer wrote into the IC and nothing else. And therefore, because I had no control over it, I decided to take back the power into my own hands and create the mother of all the boards that were about to follow, the AP, which was a lot smaller. Let me actually just compare these two to you. So yeah, this is how they look. So a lot smaller, about 40%, maybe 30% of its volume. And what I did was to get some buck-boost converters that had a higher switching frequency, because the higher the switching frequency, the smaller the inductor you can get. And also, I removed all of those ICs that had some proprietary algorithms, and I replaced them all with customizable integrated circuits for the power delivery and all of this, along with an ESP32, which was supposed to be the brain of everything. And is supposed, and it is the brain of everything. But by the way, this one has been scrapped, because all the boards that I'm going to show you right now, these are prototypes, and most of them have been scrapped for parts, because yeah, they don't grow on trees. I forgot to mention, this one has been ordered on the 12th of January 2024, so about 1 more month after the first prototype. Now, with this PCB, I managed to add one more feature to the board. So we had the power stage. Now we also have the logic stage, which is the ESP and all of its auxiliary parts. Now, for going forward, I actually spent a lot more time in trying to make a GNSS GPS module. So essentially, I wanted to have the battery be trackable so that you can track it from GPS wherever you are with a SIM card, and that would have taken a lot more time and money, of course, because that chip was really sensitive to moisture, to soldering it back again, and it was a huge problem to me because I spent like 2 or 3 weeks just studying the datasheet for that entire IC, and I didn't even end up ordering the PCB for that project. Now, one more problem that we actually have with this PCB is that it could be made even smaller if only we did not place all the programming chips. I think, no, this one. So this chip is for programming the ESP32. The other chip is for programming the main USB-C power delivery integrated circuit. Well, if we removed these parts from the board, we could even save like 1 more quarter of the total space that is on this PCB. And that's exactly what I did. So I created a programming board specifically designed for programming other PCBs. And it has the programmer for the power delivery and for the ESP32, along with a breakout for the fingerprint module, because I don't think I mentioned this, but after this PCB actually thought, why shouldn't we have a property instead of a battery? Because all power banks right now, you can take them from your friend. So your friend leaves them on his desk and you say, well, this is mine now, the communist anthem, and I can charge my phone from it. And your friend may or may not be okay with it, but you do it anyway. Well, introducing the concept of property that I thought of. Because if you introduce an extra layer of security using a fingerprint module, then whenever you want to charge your phone from it, you will have to verify that it is really you that is trying to charge the phone. So yes, this little boy was actually really useful. And after about 2 more months of work, but also remember I did that GPS GNSS module and it did not end up being produced, the official Alctra 1 was born. Now, the difference between the two, the AP and the Alctra 1, may not be so obvious at the first glance, because as you can see, they're both slightly exactly the same volume, but one is a little bit bigger on the width, but the other one is on the length a little bit bigger. However, the facts for these two PCBs are going to make it all clear. So the initial AP was not designed with any active balancing circuit in its mind, because here's the thing, most of the power banks that we have nowadays, they don't have any balancing at all, or have a passive balancing method that really just dissipates all the extra power in the resistors, and the efficiency for that is really bad. So I decided to step up the game and go a little bit higher for an active balancing with capacitors instead. And also this one was designed for only a 2S battery, so 2 cells in series, while this bigger one can handle up to 4 cells in series. I forgot to say that both the big battery PCB and the programmer were ordered on the exact same day, so on the 3rd of March 2024, which was, by the way, my birthday. Now, as I said in the beginning, I'm a huge fan of iterative processing, which means that in the first version of the battery, we had a lot of issues. So first of all, the balancing circuit design was completely wrong. It wasn't wired properly. Secondly, we didn't even have mounting holes. As you can see right now, we have some mounting holes here in the corners. And third, there was no breakouts for the USB-C power delivery circuit. So therefore, I could not program it at all. And of course, I just came back to my laptop and created a version that fixed most of those problems, then sent it to GLC PCB, and then just had to wait for them to arrive. Now, one mistake that I did during this waiting period, because I ordered the big battery and the programming PCB both at the same time, so I had to wait a little bit more than I usually would. In this meantime, I was like, why shouldn't I make my own charger, my own USB-C charger? And this is a big mistake that I made. And now I wouldn't want to say that all of those money went for nothing. But when I assembled it, it was so wrong, the design and everything, because I had no experience with alternating current and all of this, that it instantly turned into a firework. But of course, it was a great learning experience, because now I know how most of our wall bricks work, the ones with USB-C power delivery though. Now I guess it's how they say, if you chase 2 rabbits, you catch none. And after I realized that we wouldn't have any charger anytime soon, and after spending 4 entire days on it, all I wanted was to simplify all the tasks I had to the bare bones. And that is how the Alctra 1P was born. Now you see, we have quite a little bit of unnecessary logic on the main Alctra 1, so I wanted to just make my life more simple, and I just scrapped most of the things. I have like 3 main circuits here that could be scrapped, and I removed them to get a much simpler version of this huge boy. Now, of course, the Ultra 1P was smaller, but it was mainly because I chose a different power delivery integrated circuit, and not for Texas Instruments, but from Infineon Electronics. However, there was just one problem with the Infineon circuit, and that was that I did not fully understand how it worked. Now, I don't want to go into technical details in this video, but if I have to rely on black magic to do things for me, then I'm going to switch to something that I understand. And that was the main advantage of the Texas Instruments IC, because everything was completely explained, every single detail of it was explained from the beginning to the end, and so that one had a much better documentation than the Infineon had. Which in the end really just made me choose to switch back from the Infineon to the Texas Instruments IC, and here the problem started, because as I said, nothing is rainbows. No, it's never rainbows. So every single circuit has its problem. Everyone has its trouble. So this circuit with the Texas Instruments IC, even though I could program it in the end game, like towards the ending, towards closer to the competition, it just wouldn't want to behave the way that I told it to in the program. And I tried everything. I tried placing some more solder. I tried to place some more ICs, brand new ICs, brand new memories, brand new SPI memories, and nothing worked. Or at least, nothing worked reliably. Because there were some moments when it did indeed work, and those were some of the happiest moments I've had in my life. However, it was not reliable. Whenever I plugged it into the wall plug and then unplugged it, it didn't want to behave the same way that it did previously. And because of this, I just had no way of fixing the power circuitry. And I actually called this period of time the death spiral, because ever since the end of March to the beginning of May, when we had the competition, I was just rounding up in a circuit, constantly just trying to fix the IC. Whenever it worked, trying to see how it worked and why it worked, document everything and write it on my WhatsApp group, only to see that when I do exactly the same thing on a brand new PCB, it wouldn't work. Now, if I were to stay there and focus on the power circuitry on and on again, then I would have just gone in the circle constantly, and I wouldn't have had anything to present at the competition. It would have been just a concept and nothing really done on the PCB. So towards the ending and like the beginning of May, I just said, just leave it. I'm leaving the power circuitry. I removed all the buck boost converters, the power delivery integrated circuit, and I just focused on what we had and what worked. The balancing circuit, which, well, it was a double-edged sword as well, because it didn't work once. It was my mistake. It had 3 possible critical issues, but I solved them afterwards. And by the way, because we did not pay attention to it, well, going forward, I actually ran out of space and the filming just stopped. So here is the MOSFET I was talking about. So you can see its outer casing, I think it's in an epoxy casing, well, it got completely burned. So I made an accidental short circuit because there was a solder bridge between two, it wasn't here really, it was on the driver circuitry. So, but it was one on one of these MOSFETs as well. We had an unwanted connection. But yeah, that's exactly what happens when you do a short circuit. So it completely melted the outer casing of this MOSFET. It's really bad. Can you see that? You can see the copper of the PCB, and it's not just there. You can see it over here as well, on this MOSFET too, on this other one as well. On this one, you can even see the metallic side that it has on the inside. Don't do these things at home, kids. But after I moved all the parts and actually placed new parts on a brand new board, everything worked on the active balancing. So the moment I went away from the power circuitry, on which I've been working on for like 2 months constantly, and I completely ignored the logic and everything, well, I actually made some progress, and it felt so good. Just it was refreshing, really refreshing to see that something worked reliably for the first time. And so just a couple of days before the competition, I just took off with the batteries as they were.